Here, so this is
Oh yeah, sure.
then we won't be able to close
It's fine. We don't need to close this. You'll be able to see now, hopefully. Just test. Why is the microphone? Testing the microphone. Okay, so today's lecture will be like 30 minutes or less even, because it's kind of a review of what you've learned in Swift so far, but I'll also be explaining some more things, like functions in more detail, and different kinds of types, like integers and strings and stuff. And we'll be, I don't know if you guys have ever heard of classes. Yeah? We talked about subclassing.
Yeah.
So that's basically, if you don't want to subclass anything and you want to create a completely new object, you would create a class. So we'll go through that. And then you'll be doing that in your assignments. So pretty easy stuff really. Hopefully you guys will be out of here by 8. Ooh. So, oh yeah, got it. Do you want me to explain to you branching?
Yes.
Okay, I'll do that now. You wait for Paul. He's coming. Okay, so remember I said that, so you know the difference between forking and branching now? Or still unclear?
Like, you guys explain it again.
Okay, so here you have someone else's account. Suppose this is Lighthouse Labs, yeah? And then here they have all the different projects which are known as repositories or repos. So like repo 1, repo 2. And these are like you would be forking these to work on them. So this is your account. So suppose you want to work on repo 2, which might be a playground assignment, or it might be an app or something. So you fork it. You fork it and it goes into your account. And now, whatever changes you make, it won't affect the original copy. Okay? So now you have repo 2 there. And you want to, so you start working on it. Of course, you have to clone it to get it onto your laptop. I'm sure you're familiar with that now. So you clone it. I'll just throw that. Okay, so now you've got a copy on your laptop. You know how to push it back, I mean commit and push. Yeah, so that's all being done in this repository, okay? there's also this thing called, like, you guys have been writing that command add, which basically adds all those files. If you're doing add period, it adds all the files in the project to this place called the staging area. But don't worry about that, because it's essentially a part of a two-step process of committing. So you're like adding it to the staging area, and then you're committing it. You can do those steps in one command, but don't worry about that. I just wanted you guys to know, because if you looked at that cheat sheet, you'll see there's like an add, and then there's staging area, and then a commit, and then a push. But don't worry about adding. Just remember to commit and push. So now branching is, so this is your repo in your account. Okay. And every time you start working on something, like if you just forked something or you just created a new repository, you're given the master branch. And when you clone, that's what you're downloading. You're basically downloading the master branch. Now, think of it as like a tree, because that's where it got its name from, branches. So you're working on the master branch, and then if you don't create any new branches, every time you commit and push, you're going to be updating this. So you'll be like committing and pushing, you update it. And you commit and push, and you keep updating it, okay? But then, as I said in like the first or second lecture, if you're working with other people, or this project is so big that you don't want to update a working version, so like you know it's working at this. This is working perfectly, and you don't want to affect like your main copy of it. You create a branch. Okay, you create a branch, and so now your master is not being affected. Other people can create their own branches from there, and they won't have any idea on what you're working on.
Okay. And that's the time I'm going to create the request to merge master.
So yeah, so then when you're done, so like you added a feature, like I usually create a branch for every feature I add. So if I'm going to add like a new view controller, I'll make a branch, add that view controller with all the designs, with all the code, and then when I'm ready to add it back to the master branch, remember you have to always, even these side branches, you always commit and push, and it'll update this branch. So like that's a commit and push, and then you can do that however many times you want. So when you're ready to merge it back into the master, you push it, like suppose you've just done that, and then so you're gonna go back here, and that's called merge.
Pushing it back to the master is merging it.
Exactly. When you're trying to fuse them together. And when you do this on the GitHub, you have to do this on GitHub itself, like the website. Because there they offer this thing called a pull request. So when you try and merge something, before you actually complete the merge, you have to do a pull request.
What is it? A pull request?
Yeah, pull request. Sorry, can you read that?
Yeah.
Or not really?
Yeah.
Okay, so you do the pull request. Usually, like it's a big green button. I'll show you guys on the website. It's a big green button. You do the pull request. Somebody else can review it. Like they review all your code. You can do it yourself if you're working alone, or if you know everything's working. You just have, so after you click pull request, you'll be able to see all the code, and basically it's like a manual process. If you think everything's working, then this button actually changes into a merge button. And when you confirm that, it adds it to the master branch.
So if multiple people are working on sort of the same project,
yeah,
how do you manage the merging and making sure that
Who requested his success rate is low as a merger. He's the only person to merge.
So Dennis is asking, there's multiple people working on it, and so everyone's created their own branches.
Yeah.
So like, suppose here someone created a branch, and then they're working on something. You add something, then you're asking how does this second branch merge if the original copied, like the original branch it copied from was different.
Change, yeah.
Yeah. So then GitHub uses like this time scale to see what are the latest changes. GitHub will know that someone has added code here, it's been reviewed, and it's working. So when this guy merges, it won't compare it to his original copy. It'll compare it to this, and then if there's any conflicts, it'll ask the reviewer to resolve the conflicts.
Right. Okay.
Otherwise, if there's no conflicts, the reviewer just presses confirm. So like GitHub is so powerful that it knows, like, okay, this is the latest.
It basically
version.
knows what changed.
Exactly, it knows exactly what changed.
Yeah. Okay.
So you don't have to worry about anything apart from.
You don't have to worry about anything getting overwritten.
Yeah, exactly.
So if you make a change and you merge it, you're not really concerned about somebody else merging their change and overwriting.
Yeah. So the only time you'll have to do like a deep review is if you get a merge conflict, which rarely happens, but you can imagine it happens sometimes.
Yeah.
If I edited the same line of code, so if this guy edited the same line of code that this guy edits, then it'll ask you which line you want to keep, and it's got a good visual interface, and it'll show you exactly which two lines they're talking about. You just delete the one you don't want and press confirm. So yeah, GitHub is really powerful.
You ever use Bitbucket?
No, never. But did you say Gitbucket or Bitbucket?
Bitbucket.
Oh, no, I'm not. Have you?
We use it at work.
Oh, okay.
And it's a little bit. It just replaces GitHub as a central repository.
Right. Okay.
Right.
Okay.
And and it kind of is all your own stuff, right?
Yeah.
It's
So
your own account.
yeah, I get. So I think it's just a different software.
Yeah, but you still
uses
use
Git.
Yeah, but you still use Git to like commit and push and pull and stuff like that.
Yeah. So I think there's actually a few different programs like GitHub and like Bitbucket that you could use. GitHub is definitely the most popular one, but it's interesting why you guys use Bitbucket.
Well, it's an Atlassian product. We already were deep into the Atlassian. We use a lot of their Atlassian tools, Confluence and stuff like that.
Right.
So I guess Bitbucket was just part of it, so they decided to use Bitbucket.
Interesting.
Yeah.
I actually want to take a look at the differences. I'll do that later. Okay, cool. So I think let's just start with this now. Can one of you guys check if this stream, I'll send you guys a screen, just let me know if it's working.
So I,
Yeah.
Yeah, that's working.
It's working?
Well, that's cool. You're like this little person in front of a huge screen.
I don't know if like it's lagging on this computer, but
No, it's totally like. Oh yeah, it's behind on
it is behind, like really behind. It's fine, whatever. We can deal with that later. So, okay, intro to Swift. So you guys know quite a bit about Swift already, but there's a lot you don't know. Why is this not changing it? Okay, so playgrounds. As you guys know, it's an Xcode feature that lets us test Swift code. You guys know that. So there's a few keywords I want you guys to know right now before you get confused. First of all, the playground file is a text document, so you don't get all the features that Xcode, the software, provides you. When you open a playground file, it just redirects you to this little tiny part of Xcode called Xcode Playgrounds. So in Playground, every time you type something, the computer is compiling it. Do any of you know what compiling means?
Yeah.
Yeah? It means translating it to machine code, something that the computer understands. Because Swift is something that we understand. The computer doesn't understand it. So it needs to be translated into machine language. That's what compiling is, translated. And then once the computer understands everything, it runs it. And that, I'm guessing you guys know what running is, because it's just like executing or doing whatever you programmed it to do, or basically showing you the results. Okay? So when you guys are typing and you see a red error, that means it hasn't been compiled. Meaning the computer doesn't understand what you've written. Maybe because you misspelled something, or you missed a bracket somewhere, or something like that. It means the compiling has failed, okay? If the compiler fails, you wouldn't be able to run, essentially. Yeah, so Playgrounds is a place to experiment with code. You probably wouldn't be using this after week 3. Yeah, because instant results are shown, and it just makes it really fast for beginners to learn Swift. Cool. Okay, so these topics. So you guys know, you guys have gone through variables in your assignments. You've gone through types a little bit. Type inference, you guys know what that is? Probably not. No? Okay. Functions, you went through a little bit. Classes, you haven't gone through at all. Attaching functions, classes, and control flow. Okay, I'm going to go through each of these in Xcode now. And you guys can help me out with some examples. Where's the mouse there? All right. Dennis, can you read that?
Yes.
I tried to make the font a bit bigger, so hopefully it's good enough. Okay. Okay, so variables. This is an example of a variable. We're saying variable string is equals to playground. Okay? Easy, right? You guys have gone through this a lot of times. I'll write another one. Variable person 1 is equals to. Okay, so now I'm going to write a variable using the keyword let. And you guys have probably seen Xcode auto-completes pretty much everything you type, unless you're typing in a new word. So if I'm going to define a new variable, it wouldn't auto-complete this. So if I'm typing student, it's not going to auto-complete that because it has no idea what a student is. And we'll write this. Okay? All good with variables. So now, the next thing was types. You guys know what types all 3 of these are, right? They're all strings. And Xcode actually automatically guesses what type you've given it based on the value after the equal sign. So if I said let x equals to 3, it knows that, okay, x is going to be an integer. But this is where things can get interesting, because I can actually give the variable its own type, so that later on only that specific type can be assigned to the variable. So I can say var y.
So what's the difference between var and let?
Oh, okay, so yeah, I didn't explain that. So let is saying, give this variable x the value 3 and never let it be changed again. Whereas var is saying, okay, give this variable student the string Vince, but that variable can be changed in the future. So let is like a final representation of that variable, whereas var means it can be changed later on. So if I tried to change x, so if I said x is 4 now, it's going to be like, yeah, cannot assign to value x, let is a let constant. Cool, but if I did student is equals to, yeah, it will let me do that. Oh no, that's also a let, sorry.
Person
1. There. Yeah?
So it's like you're saying person 1 is now.
Yeah, so now person 1 has got it.
Okay.
Yeah, reassigning it, basically.
Yeah.
Okay, so back to type inferences. So now if I wanted to say var person 2 string, this is how you can say make sure person 2 is always a string. And you wouldn't be able to, so I can do this now. Person 2 is equals to Dennis. Yeah, I can do that.
Would you let person 2?
If I did let person 2 string, then I wouldn't be able to change this later. Yeah.
So if you go person 1 equals 3.
So person 1, yeah, so now I'll do that. So person 1, or even person 2, let's do person 2 because I gave it a specific type, is equals to 3. It's not gonna fail. It's gonna fail, yeah. Cannot assign value of type int to type string. Okay? So this is like using this semicolon and actually explicitly telling the variable what type it's going to be makes sure that it's always going to use that type. And it's very important because like if multiple programmers are working on a project and say there's a variable name that's quite ambiguous. So like if I have a variable called trying to think of something.
It could be like ID.
Exactly, ID, yeah. Very good. Okay, so if I said variable ID,
Because an ID could be like a string or like an alphanumeric.
Yeah.
Or like a
yeah.
or
So if I said variable ID is that. And now ID is 3. This, let me comment this out. It's not going to work because Xcode automatically inferences this is a string and says, okay, now every single ID is going to be a string. So it's automatically doing this step for you. You don't need to write this, but it's always good to write that. So if a programmer is looking at your code, he automatically knows, okay, this variable is a string, without him having to guess and like make mistakes. All right, so okay, so we've looked at strings and integers. Does anyone know any other types? Floats. So we can say var float 1 is equals to, it's good to float. I don't think the caps matters, but let's just keep it like that. Float is equals to true point 5. You guys know what a float is, yeah? It's a decimal point. There's another type of decimal point called a double. But the difference between the two is, you wouldn't need to know this for this course, a double is more, a float is more precise than a double because it's got more decimal points. So if I say doubles, give it like 2.9 or 2.8, yeah? You wouldn't be able to see like the full thing here because it's showing us like, basically if I gave it a really long number, I think it'll have a cap as to how many decimal points it is. You can see this one. I'm not tried this before in Playground, but yeah, okay, so doubles are more precise. They've got more decimal points. Does everyone understand that? Yeah? Vince? You'll typically be, if you want to use decimals, you'll typically be using doubles. Just because like you're allowed more decimal points and therefore it's more precise. Okay, then what did I want to do next? Let's go to the slides. Okay, functions. So, you guys remember how to write a function? I'll start it off with you.
Is it like func?
Yeah, func. And then the function name.
Yeah, the function name.
So, tell me something. Give me a name of a function, or like a function is basically like something you would describe in a verb. So if I want to
get username or something.
Yeah, okay, get username.
And
Parentheses, and then curly brackets. That's the most basic kind of function. It doesn't take any parameters, and it doesn't have a return type, which I'll get into just now. So in here, we could write any code we want. We could say, okay, print person1. Oh, I don't even need the speech marks. Print person1 or 2. Okay. And so now every time we call get username, that's going to print. So if I say get username, it's going to print down there, Dennis. So functions are a great way of reusing code. That's basically what their purpose is. You don't want to be rewriting some code over and over again. You just want to write it once and then use that name of the function and execute everything that's in the curly brackets. Because suppose in here I wanted to do many things. I wanted to say let's use the variables we have. I'm going to say person1 is equals to a new person. We can say it's now equals to Sanjay. And then print person1. So get is this a, why is that not running? There we go. And then later in the program, I can call this again. But why? There. So you guys can see it's easier to write one line of code rather than two. And functions can actually get really large, as big as you want them to be. We're going to go into a more practical example just now, but I just want you guys to understand why we use functions.
Can they be used at a global level? So can functions be called from different parts?
Yeah, exactly. So they can be. So if you have a function in one file, you could call it in another file.
Oh.
And so I'm sure now you can understand why they're really important. Yeah. Yeah, you understand why we use functions? Yeah, Vince?
Yeah, I'm getting there.
Getting there.
Yeah. For some reason, like when I type it out like that, it's not.
Let's see what's happening.
Oh, it's still running. It's because it's still
Oh,
compiling.
oh.
Yeah, so even if you fixed it, I've seen that in mine too.
Okay.
Okay, so you know what I did? This was happening with my laptop and with Gane's laptop.
Sometimes I quit Xcode and reopen.
I found a shorter way to make it work. So
Oh, really?
just click this top right button, and changed the platform from iOS to macOS. This is just like a buggy fix.
Oh.
And apparently running Playground with a macOS simulator is a lot faster.
Okay.
So
Alright.
let's see if that works. Running. It's ready.
Cool.
Still not giving it.
Um,
Okay, anyways, just
What I do is I just quit out of
Quit it.
Xcode and then reopen it, the file again, and you.
also this button reruns it. So if you want to click play, yeah, and see if it prints. Okay, it's not. Anyways, let's just see if you can get that to work. But no issue if you can't.
Alright.
You can just follow along and then
Yeah,
we'll
once
get that
I
sorted.
called the function, it did it.
Okay.
I guess I'm just having a hard time. Like, do these come into play as we're trying to create like the actions within our storyboard? Is that
Yeah. Okay. So now, not exactly the action, not those IB actions we're talking about, because those IB actions are only called from the storyboard. That's why they're called IB actions,
Right.
interface builder actions. And so you won't ever have to call the name of those actions yourself. It's only called when a user taps something. You get that? So you
So what's
can,
the difference
yeah.
between like an action and a user tapping something?
Yeah, so an IB action is when a user interacts with the screen.
Yeah.
And that's what we've been saying actions are.
Okay.
Functions are actions, but they don't rely on the user input.
Got it. Okay.
These functions are being called by the person writing the code. So like if I want to, whenever the developer wants to use a reusable part of code, that's when you call the function name.
Okay.
Okay, so I'm gonna show you a more practical example. I just wanted to make sure you guys have the gist of that. Okay, classes. So this writing function is going to be it's going to make a lot more sense when we have a class.
Can I just ask one more question?
Yeah.
So are you basically like defining all this stuff first and then using it? Is that kind of how it's set up? Like
Yeah. So basically, at the
you're
top
defining that function and then you can.
Yeah, and then you use it later.
All right.
That's so when you're developing an app or something, usually like write out type out all the variable names. You define all the functions. You're not using them yet, and then after you've done that, then you start writing the logic of your app. Like if the user does this, like use this variable, or if this variable changes to something else, then execute this function and then call it like that.
Makes sense.
Yeah.
So you look at all the behaviors that they could possibly have. You write the functions and then you piece it all together. Like.
Exactly. Yeah.
Okay.
So next thing we'll quickly talk about are classes. To define a class, we just do this. You just use the keyword class. Say what the class name is. So we usually use a capital letter for like the first letter of a class name. So I'll just call this person. And don't use that because we're not reusing these two variables. We're creating a new complete. Maybe I'll use a
So
different
class is
example.
usually just like objects.
Exactly. A class is an object that you're going to have multiple instances of. So because like there's 4 people here, if I want to use our data in an app and I don't want to create 4 different like instances of us, I just create one class called a person. I'll just use this example because we're going along with it. And then we open these curly brackets, okay? You'll get used to the syntax, so don't remember about the syntax for now. Just remember the keyword class name, open the curly brackets, and now we can write the different properties of a person. So we can have like, every person has to have these things. So we can have like var height, which is an int. Okay. Another property of a person.
Name.
Yeah, our name.
Or could even be like first name, last name.
Yeah, we could do that as well. Don't worry about this for now. I'm gonna show you how to initialize. Give me another. Hey, what's up, Paul?
The downtown is under total gridlock, you know?
Because of that.
Migrates.
Yeah.
Gas time grab.
Oh, God.
So guys, let's wait. So yeah, we wait. And yeah, age. Okay, I'll write that as the last one. Age. So in the real world, height would probably be a double because like no one's, unless you're measuring it in centimeters. So okay, whatever. You guys know. Okay, so now we have a person that has these 4 properties. By property I mean like attributes. You guys get that, yeah? And now the error it's giving me is saying this class doesn't have an initializer. So like that means we have, whenever we're creating a person, so if I want to create myself, I need a way to assign like my values to these variables. And to do that, we just write init. As soon as we write init, it's going to autofill everything. We just have to click enter. I'll do that again so you guys can see what's happening. So init and press enter, and it'll give you like the brackets exactly where you need them. So now you need to give it some parameters. Every function, I'm going to go back to this function here. Every function can take in parameters or none at all. This one's not taking any parameters. And it can also have a return type. So if I didn't want to print this, and I just wanted to send my name back to where I called it from, I could do this. Which is saying, okay, whenever this function is called, like here and here, send a string back to where it was called from. So now,
So must have a return value.
yeah, so then if you do have a return type, which is a string, you have to have a return value. And a return value means whatever you want to send back to where it was called from. So you just have to say return, and then I can say
Person one.
first. Yeah, person one. And now you'll see that these 2 lines, when it runs, I have an error. Okay, I'll just do this. Comment that out for now. Whenever I call these 2, my name will be printed out there on the right. Cool? So this function is returning a certain value. In this case, it's returning a string. You just have to say what type it's returning. You don't have to say anything else because it can be a different value each time. Like this might be something else if you wanted to have like a different value. Anyways, for now, just remember functions can have return values, but you have to specify the type of a return value.
What's it returning it to? What do you use?
Oh, so in your program, you're going to be using this function in different places. Like in your apps, suppose you wanted to send your profile data to the internet. And you'd write a function for like gathering your labels text or your profile image data, and then you would want to send it to the internet. So you would typically write all that all that code in a function, and then when you want, like, so when the user clicks upload, you would just have to write this one line of code, which is the name of this function. So don't worry about that. Okay, just remember we can have return types. All right, I'm going to uncomment this. Parameters I'll go through right now. So, I'm just going to do this again. Suppose that you're in your code and you wanted to give it so you want to call this function, but you don't want to use any existing variables. So, suppose you wanted to say get username. This is a very impractical example, but I just want to show you guys what a parameter is. If you wanted to pass in some value into that function, you'd write it in this first set of brackets, like the round brackets. So if you wanted to pass in a string into this get username function, you could say x or whatever the name of the parameter is, that doesn't matter, and the type of that parameter, okay? And so now we can say, we can use this in this function and do anything we want with it. So we can say x or person1 is equals to person2, which is Dennis, plus x. So I'll do this. Okay. So this function now is taking Dennis's name and adding whatever string we pass into it. You'll see that now it'll give us this error saying missing this argument for parameter x, because every time we call this function, it needs those parameters. In this case, there's one parameter, which is x. So if we give this a little string, say x is now, what's your last name?
Cruz, C-R-U-Z.
Cruz. Okay, and after it runs, it's going to print Dennis plus Cruz. And we can add a space there as well. There we go. So now we have the space. Okay, Vince, or all of you, you get why we can, or how we use parameters and return types. Okay, so now that we can do that, we're gonna create this class object. Okay, Vince, I can see you're not quite understanding.
I just don't see how it fits. Like
How it fits.
I'm just not seeing like the practical use.
Oh right, okay. So let's get into the more practical side now. So we're gonna create an object which is a person, Is it confusing if I use person again, or should I use a different? I'm going to use a different thing so we can.
Human.
Human. Okay, yeah, let's do that. Human. Okay, so every human has a height, a name, a weight, and an age. And so if we want to make a human, we have to call this init, which is a given thing for every single class. Every class needs to have this written. And then we can say height input, name input. We can even write imp, it doesn't matter. These are just the names of the parameters. And age.
So sorry, just to kind of reverse a little bit. Why do we have to initialize the,
Yeah, so
the attributes?
So you have it's just a Swift. It's part of Swift.
Okay.
Like that's the best way to initialize an object, just by calling this init method or function.
What does that mean, initialize?
It means initialize. So initialize is creating an instance of this human. So if I wanted to create an object called Vince, I would have to. That's what I'm going to do now. And then we can say height is equals to him. Name is equals to.
Oh, so that's the way you can assign values to those attributes.
Exactly. I'll explain that right now. I just need to finish. I should have probably used two variables because it's taking me some time. And age. All right. So now, if we wanted to create an object. Weight is supposed to be an int. Okay, don't worry about that. Like, you're gonna see why we use this. So you've created this class, and now you're in a different file. Like, suppose you're in a view controller file, and someone has just created a profile. After they've hit the enter button with all the text fields filled out and everything, you would have to do this. Let's say. Oh, it's human. Sorry. You'd have to create a variable called human. Human1. And say human, remember it has a capital because it's a class. Open bracket, and you'll see that the initializer is automatically going to present itself.
So this will receive all the inputs that come in through the.
Yeah, exactly. So now if I press enter, it'll give me 4 options for the 4 parameters I need to include when I make this object called human1. So height input. We can say whatever, 30. Name, I'll say Paul, just came in. Weight, I'll just try 10. And age 20.
So if it was coming in from an actual view controller, would all those be variables? That are storing values?
Yeah, so as I was saying, if we're in the profile page, and suppose we're actually logged out, so we want to create our own profile. And when the user hits submit, we can fill in all these values with the data from the text fields. And when we use this human open bracket with all the parameters, that's going to call this initializer. Don't worry about why it's not using this init again. That's just the way it is. When we want to make a human, we don't need to call init again. We just have to do human open bracket, and all the parameters will be available to us. And that's how we create it. And now we can use our human anywhere. So we can say, if we want to find out human1's height, we can say human1 dot, and it gives us the different properties of a human. And we want its height, and it's going to tell us what his height is. 30. So using that, that's how you access the different properties of a class. You just have to write the variable name dot property name. Okay?
So you can like, once you have access to this stuff, then you can write logic to like do different things.
Yeah,
with
so-
properties.
so-
it could be like if the human's height is less than this, you put it in a stored in a group of.
Yeah. So that's what we're going to do next. We're going to use this human's properties and do stuff with it. So, okay, Vince, so like we've created, suppose we're in the login page, sign in page. We've written all our details. We hit the enter button. This human, open bracket, close bracket, is going to initialize a new human, which is your profile with all your data. Once that's done, you have all your data stored in this human1 variable, okay?
So is this type of, like, would this be used, like you said, if you were creating a profile, things like login information,
Yeah.
birthday?
Yeah, so all that would be different, those would all be different parameters.
Okay.
Okay, and then now you're in your profile page and you want to see all your data. So then you would use these different properties and like show them wherever you need to show them. Like in that image view, you could say, suppose there's a parameter with an image. I could say profile. This is not going to compile, but this is how you do it. So, profile image view dot image is equals to human1 dot image or profile, whatever, if you had that variable there. Okay, so you can see like why we need classes, because we want to keep all of this there so that every time we create a new person, we don't rewrite all this. We just have to do this one line.
So that's the type of thing where it would show up and they're putting in the actual information there, and
Yeah.
then we store it, and
Yeah, and then do whatever we want with it, or whatever they want to do with it.
So this is basically like the logic that interfaces your app with, say, like your database.
Exactly, yeah. So
all the
like,
data coming into your app comes through this logic, and then whatever you, based on what you're doing in the logic, goes write these attributes to the database,
yeah.
or retrieve
So
them from the database, and then we present them on the screen.
exactly. So remember in the first class or the second class, I talked about the MVC pattern, which is used in all apps, like most web apps, all Android apps, and iOS apps, because it's model, view, and then controller, right? So all of this that I'm doing right now is part of the model. And then the controller, which binds the two together, uses this data and presents it in the screen, which is the view. So I will redraw that. Okay. It's not a great drawing, but I hope you guys understand that. Everything I'm doing here is part of that model aspect. We're not doing anything that relates to the actual storyboard or the view. The view controller, which uses this, which we're going to get into, you guys are going to do that in your assignment. You guys are going to be creating a class called, what is it? I think it's person. Yeah, you guys will be creating your own person class, and that's how you'll be creating your profile. And you'll also be creating another class called post, which holds all the information of your selfiegram post, like the image, the caption, the amount of likes, and all that. So you're going to be creating those two classes today. There's guides on these. There's a guide on these exact steps that I've done So you'll get more familiar with that. Cool. So now, what is next on the thing? Attaching functions to classes. Where's my mouse? So this init function is a required function in every single class. You can also add additional functions. Suppose you wanted to find the BMI of a person. Like when you create a human, the human is not going to know its BMI unless like he already knows that from before. But this is an example. If you wanted to find his BMI, you would say func get BMI. Parameters would be what you need, your weight, which is an int, and you need your height, which is an int. And we could return the product of that, which can be, we'll say like, okay, return the decimal value. It could also be an int, because if you multiply two integers, you can only get an integer. But let's just use double. There. Okay, so who knows how to get the BMI of a person? Does anyone know?
I have no idea.
Oh shit, you guys, okay.
Body mass index.
Body mass index.
Oh, body mass.
Is it weight divided by height?
It might be.
I don't know, man.
Okay, we'll use that. Weight
Here,
divided by
Let
height.
me see.
Yeah, find out.
I thought it was more complex than that. That really makes me not trust it. But
Divide your weight
it says
by-
kilograms divided by meters squared. So
Kilograms divided by meters.
that's what it's. The formula is. Yeah, that's what it says.
Is
Divide
this
your weight
squared?
by height, and then you divide it by your height again.
Wait, is this squared just for the meters or for the whole thing?
For the meters.
For the meters.
Yeah.
Okay, fine.
Yeah.
We'll just use that. Wait, okay, so we need to first do okay, so what's this gonna be? Variable BMI is equals to, okay, we'll say this is our double, and it's equals to the weight
Divided by height.
divided by height squared. Will this be times height?
No, there must be some other way to
Oh, right.
square.
Cannot convert that.
Okay, then you have to convert this to a double. But so for this, I'm just gonna do this. Let's not mess around with doubles for now. Okay.
What would be the advantage of having that as a double?
So
A more accurate.
yeah. So
Okay.
if your weight and your height were not integers, like not whole
It's gonna
numbers.
give you the closest.
Yeah, so like if our weight
I see,
was
I
like
see.
30.6, and if you multiply that even with a whole number, you're gonna get something that's a decimal,
Yeah.
right? So then you need to return a double because it will be
Okay.
more accurate.
Okay.
Okay, so that's that, and then we have to return this because we've specified that there's a return value. So let's say return BMI. All right. So now we can. Yeah. So since I didn't change this after this line, this doesn't have to be a variable. It can be let. Sorry, it doesn't have to be a var. It can be let. And that warning goes away, but it doesn't really matter. It's not an error. It's just telling you. It's just telling you. Yeah, it's just a warning. It's just saying you haven't changed this, so like you can also use a let. So then here we can say human one dot.
But how come
Yeah,
we're
yeah.
returning integer?
Oh yeah, because like if you do an integer, which is this, divided by the product of two integers, you're gonna get an integer. Yeah. If one of them was a decimal, then you would definitely get a decimal. Okay, maths, I know. It's difficult for me as well. Okay, so human 1. So now we want to get the BMI of this human we just created, whose name is Paul. We do human 1 dot. We'll see all the names of the properties and all the names of the functions as well associated with that class. You can do that. And here, okay, so here I'm going to rewrite the values. His weight was 10, height was 30. Okay? And so it's going to return whatever the BMI is. Let's wait for that. Okay,
So is a function the same thing as a method?
yes, function is a method. Essentially, it's a verb. Okay, it's taking a long time to run. Why?
Is your thing set to iOS?
Yeah, I said no. I set it to macOS, which is faster. But this is the problem with Playground.
Is there any way to like compile on demand, to change it to compile on demand
Instead of auto compile.
Yeah.
Maybe actually. I haven't looked into that. But yeah, you could find out. Actually, that would be helpful.
Weight 10 and height 30?
Yeah. So here I've given it my own values.
Yeah.
But if you want to use human 1's values, you'd have to say in your declaration of the function.
No, I'm just thinking,
Yeah.
how come if you divide 10
Yeah.
by 900, you're going to get an integer?
Yeah, it's gonna get a decimal.
I see
Yeah,
my maths is
Mine
so-
came out to 0 because it won't spit out. Yeah.
Okay, so that's probably why it's taking so long.
So how do you?
So now if it gives you this error saying like cannot convert this into this, you can use this quick fix which basically converts that into a decimal. Okay? And this is the same warning we were looking at earlier. So yeah, if you want to like force something to be a decimal and it's an integer, you just have to say double open bracket your integer close bracket.
If you on the bottom you know the play button.
Yeah.
If you long click it, it'll give you the option to either automatically
Oh,
run or
nice.
manually run.
That's sweet. Now let's see if it works.
No, it's still 0.
Still 0.
That's mine's saying that, but I think it's.
Let's give this like better values.
Yeah, let's try.
Like 100.
Well, I'm just gonna flip the height and weight. That should be.
Okay, like, anyways, you guys get the picture there. If I wanted to use human 1's actual variables without writing them again, you'd do that here. You'd have to say in your function declaration, get BMI, weight name would be an int, and here you could say, okay, so we wouldn't even need this, but I'm gonna do this again. Class, I'll create a new class. Class name, give me a new class name, guys.
Car.
A car, yes. Car. Square brackets. We'll say var. Color. Which is a string. And I just want to give it one more variable, which we're going to update or change. Price. Okay. And then remember, you need the initializer with some parameters. What did I give these ones?
When you declare something as a float or a double, can you specify precision, like in terms of like how many decimal places, or does that have to be a completely different type?
I think you can. I'm not sure how you do that though. Yeah, I've actually never specified the precision before. You can just Google that. But yeah, price and which is an int. Okay, so now say color is equals to color in and price.
Is INP just standard practice for input? Like this?
Yeah,
Okay.
yeah. I could call this whatever.
You can call it whatever, yeah.
All right, so now we want to add a function to this card, and I'm going to call this function raise price or inflate price. Okay, we're not going to give it any parameters. We're going to give it a return type. Because remember, you don't need parameters. You also don't need return types, but you can add whichever one you want as you feel necessary. Okay, so this is going to return an int. And here, we're going to say inflate the price or return price times however many zeros. That's like 10 million or something. 100 million. So we're going to inflate the price by timesing that by 100 million. Okay. So now, let's create our car. So we say var car1. We can say this, and which is better. It's better practice. And say car. Now I made a mistake here, and I should have made this a capital. I'm just trying to make more space. Okay, car, and so car, we initialize it, just open the bracket and press enter, and it'll tell you what you need to fill out. You can say it's red, and we can say it's worth $30 or whatever. Okay, so now we want to inflate the price of this car. So we do car1, as we called it that, inflate price, and the results should show here if our thing runs. I need to comment all this out. I think it's still giving me an error somewhere. It's taking too long to compute. All right.
Can you give an example when you want to pass some parameter function?
Into a function? Okay, so in your self-program app.
No, just like here.
Oh, here? Oh, right. So if you wanted to do say func
So if you
say
say you wanted to like
yeah.
base the car price on color.
Okay, right. Okay, I'll do that next, but I'll do a simple version. So suppose you wanted to inflate the price by something else, something that's going to change, not 100 million, okay? So if you wanted to inflate the price, I'll call it inflate price by user determined number. Remember, you can call this anything. You can say, okay, my user determined number is going to be an int, and it's going to return an int. open the bracket, and then we can say return price times the user number. Okay, and so now when we want to use that function, we do the same thing. Car1 inflate price by user determined number, and we say, okay, this time I want to inflate the price by 200. And then it would be a different result to this. This thing is so annoying. Why isn't it running? I'm gonna close this and open it again.
Yeah, mine's still running too.
I can't even find this file is not open. Okay, there we go. Hopefully it runs. Oh my god.
Yeah, mine too.
This is frustrating me. Okay. Anyways, I hope you can see why like we need parameters. That's like the main takeaway here. If you want to tell the function, do this with a new variable, something that you're always going to be changing whenever you call that function, that's when you need a parameter. Yeah, this is just annoying me now. I want to go through what Dennis was asking about logic. So you were asking if a car is a certain color, can we inflate the price based on that, right?
Yeah.
So to do that, so we had created a new function in this class saying func inflate price based on color. And we have the color and the price in this class, so we don't really need the parameters. And we can return the int. Okay, so open the bracket, and now you can say, this comes down to that logic we were talking about in the first few lectures, ifs and elses. You guys did a bit of that in your playground assignment. You can say if color is equals to red. Open the bracket. Return price times whatever. Like say red cars inflate by 100. Else if color is equals to blue, return price times 50. So blue cars are worth less. And then we can keep writing else ifs for every single color, but I want to keep this short, so I'll just say else. So that means if the car is any other color, return price times 2. Okay.
What about the inflate price from? Wouldn't the system be returning inflated price? Inflate price based on color.
Yeah. So here we're going to, there's 3 situations. If the car is red, if the car is blue, or if the car is any other color. So that means only one of these 3 blocks is going to run. Because a car can't be red and blue, and it can't be red and something else. So that's why we can have these 3 return statements in each block, because only one of them is going to run. Alternatively, as I was doing earlier in the other class, we could create a variable, an empty variable, say new price, and say it's an int. Okay. And then we could assign that new price to this value. So we can say new price is equals to that. And then new price is equals to that. New price is equals to that. And then after all these if and else's, you'll have to return that new price. So we can say return new price. And that's basically a function with some logic inside, which is the building block. These are the building blocks of every single application. These ifs and else's are used everywhere. So yeah, it's pretty important to understand. It's very simple if you have cases where you need to, if you have variables that can offer different things, and you want to give results based on those variables, you would have to use ifs and else ifs and else's. Dennis, does that kind of answer what you're asking?
Oh yeah, totally.
Okay. And then again, we can call that by saying car 1 inflate price based on color.
So we basically can pass the color parameter, right? And then
Yeah,
logic.
Exactly. So in this case, we don't need to pass the color as a parameter because car 1 already has a color. And as we said here, it's already red. So we don't need to give it a parameter. If we wanted to use a value that's not included in car's initializer, so if we wanted to inflate price based on the location, then we would have to give it a parameter because the car doesn't know its location. Cool. So yeah.
You would put that parameter just within that particular function then?
Yeah. So then so here you'd have to say the parameter name here and its type. And then when you're calling the function down here, you'd say the parameter name and its value.
Okay.
So yeah, so it's quite important to distinguish what a value is and what a type is, because when you're declaring a function, this is right, we're declaring functions there, there, and there. When we're declaring functions, we just need to say their types of the parameters and the types of the return. But when we're calling the functions down here, we just need to give them values. We don't need to re-specify the types.
The value of the parameter.
Yeah, exactly.
Okay.
Yeah.
And that's really the user doing that, right?
Exactly. The user could be inputting stuff that gets placed into these parameters. The developer could also be inputting stuff, but it's usually the user.
For this kind of thing.
Yeah.
Like, hey, see what your car would sell for, and yeah.
Exactly.
Okay.
Yeah. Yeah, you guys are going to be doing a lot of this today, so I think the best thing you can do is get started on assignments. That's pretty much all.
Hopefully it runs.
Yeah, I mean, that's all I was supposed to cover today. And yeah, that was the tutorial. Cool. Any questions?
That was not a 30-minute lecture.
Yeah, it turned out to be over an hour. I'm sorry.
It's okay.
But the assignments wouldn't take you that long.
Wow, is Compass slow?
Yeah.
Yes.
There it is.
I think it's, yeah, I don't think it's just playground. I think everything's a little slow right now.